So now I want to talk about another aspect of web apps, which is navigation or routing. How do we do it in a React app? By routing, we mean we'd like our web app to have multiple views or pages. And as the user navigates from page to page, we'd like the URL in the browser to change accordingly. So each page will have its own unique URL address. And of course, that's a fundamental principle of the way the web works. Back in the static web world days, as we clicked on a hyperlink, that caused the browser's URL address to change and the new page appeared on the screen. What was the benefit of that? What was the reason behind it? Well, first of all, that is referred to as addressability. Each page had its own unique address. And the benefit of that was if I wanted you to see a particular page, all you needed was its unique address and you went straight to that page. You didn't have to go to a kind of a base page and then follow a series of links to get to the particular one that I was interested in sharing with you. So this addressability, information sharing, deep linking, they're all interrelated principles of the web. And we'd like our web apps to maintain those characteristics. Web apps that predate the single page app framework, they did not support addressability, which was one of their main weaknesses. So it was really when single page app frameworks came about that the addressability feature was reestablished, if you like. And in React, so one of the points I made about React when I started this module was to say that it was completely focused on the V part of MVC, didn't address any other aspect of a web app. And so that's the case with navigation. It doesn't actually support navigation at all. We need a separate library to do that, or a separate framework. There are a number of them, but one has emerged as the most popular one, and it's called the React Router library. But it is a separate library maintained by a separate community. Now, the third folder that makes up this week's archive contains various routing samples, some of which I'll talk through in this lecture, and the remainder we will look at in a subsequent lecture. So if we import this third folder into VS Code, as usual now, this was created with the Create React App, and you do the usual of npm install, npm start. Now you can see there are a whole series of samples, and the way I want you to kind of work this is whichever particular sample you want to play with, you first of all have to go into the base index.js and change that to refer to the particular sample subfolder. And once you save that, then the development server will go through its retranspilation process as usual. So here's the first sample that we want to look at. In the table, I'm showing you my objective. I want to have 3 pages in my app, and depending on the URLs there, I want a particular component to be mounted onto the DOM. So for example, if the browser's URL is currently /about, then the about component should be mounted onto the DOM. It may have siblings. That doesn't really change how I express this overall table to the React Router library, or how I express its configuration. So at any one time, one of these 3 components is going to be mounted onto the DOM. And this is how I describe this configuration to the React Router library. So it's consistent with React itself. It's based on a kind of a component model. Now in the outer components, the browser router and the switch components, they're kind of boilerplate, even though they play an important role. The browser router component, it essentially watches what's happening to the browser's URL address. And if that changes, that triggers an event, and the browser router component deals with that event. And by dealing with the event, I mean it essentially examines each of these route entries here to find a match. So if the browser's URL changes to /inbox, for example, it will realize, well, that matches this path here, and therefore it will mount this component onto the DOM. So these are components. These are components that are defined by the React Router library. So path is a prop, component is a prop, and all of that good stuff. So that's how we configure the React Router library. Notice as well that this component here, which I've called the app component, it's the one that we actually pass to the React DOM.render method. So the very top component in your component hierarchy is always going to be a React Router configuration component, which is what I have here. So what's nice about React Router is that it follows this declarative programming model, which we've talked about before. The browser router component plays the role that I've explained there a moment ago. It finds the matching route entry in the set of routes that are available to it, and it mounts it onto the DOM, mounts that route entry's component onto the DOM. The route, what I'm saying there in that point is that this path prop, it can have wildcard characters in it. So it does support a certain element of regular expression matching. The redirect, oh yeah, that's the last one there. It's always the last one really in the series of routes, and the redirect essentially avoids the 404 problem. So if the browser's current URL is none of the three that are on my table here, then I don't want my app to just throw back a 404 response. I want it to go to a default view or default page. And in my case, I've decided that this should be the default. And that's really what I'm expressing in the redirect entry here. So if and here's the wildcard character, for example. So if the browser's URL is none of the above, then I'm telling it to reset it to the /path. And of course, once the /path is entered into the browser's URL, the React router is going to make a routing decision based on that. And so it's going to pick up this route entry. The switch component, which really the switch component behaves like a case switch statement in programming. So whenever the browser's URL changes, only one of these options is going to be picked by the React router. If we didn't have the switch, then it could pick more than one, and usually we don't want that. So if we look at the full code for this, so I've got my base index.js set to sample1, and I'll restart my development server. So if we dig into the sample1, now for convenience, I've essentially put everything into one file in here. So it has my routing configuration. It's what we've discussed already. And these other components that it's mentioning are also defined in the same file, just for convenience, really. And so for now, I'm going to manually change the browser's URL. which obviously isn't great, but so if I change it to /about, and if I change it to something that it doesn't recognize, then it redirects me back to the home page. So that's the 101 example. You write your routing configuration, put that into a component, and that's the component that you attach to the DOM. The next thing I'd like to do is to have hyperlinks on my web pages. And there is a special component that comes with the React Router library to do that, which is called the link component. Essentially, if you want to have links to something outside of your app, then you can use the traditional HTML anchor tag. But if you want to allow the user to navigate within your React app, then you should use the link component. It will provide other benefits later on, as we'll see. So to illustrate this, let's supposing on my home page, I'm going to have these two hyperlinks. How do I implement these hyperlinks? I'm showing you here on the right. So here we're using the link component. And for now, it just has one prop called the top prop, which we initialize to what we want the browser's URL to change to when we click on that link. So it's going to be a string in this case, but we'll see later on that we can actually assign an object to the top prop as well. So again, what's going to happen now behind the scenes is when the user clicks on one of these hyperlinks, one of these entries here is going to change the browser's URL to a new value. That event will be picked up by the React router. It will consult its routing configuration, and by that I mean it will look at this kind of stuff to decide which component should be mounted onto the DOM, and also which one should be unmounted. And so that's what I'm kind of describing there at the bottom of the screen. Let's look at the code. So as I explained, you need to change the base index.js to now refer to sample2. Now, ideally, of course, we'd like these hyperlinks to be constant across all our pages. We'll see how to do that in a later sample. The next feature we want to look at is what React Router calls dynamic segments. More commonly, this would be referred to as parameterized URLs. So if you take the example here, supposing I've got an app and this is one of the URLs that it needs to support, but the idea is the 22 here is a parameter or a variable. Maybe in this case, it represents the user's ID. And let's supposing the component that mounts as a result of the browser's URL changing to this, that component would display this particular user's profile. Later on, maybe the URL might change to /users/50, and then it would display user 50's profile. So the component is adapting, or it's extracting information from the browser's URL in order to display relevant information rather than being purely static information. Similarly over here, maybe the component that's mounted as a result of a browser showing this path name would display a list of purchases made by user number 12, but clearly the 12 here is variable or is a parameter. So how do we express URL paths that have parameters buried within them in React? And secondly, how does the component actually extract the parameter in order to use it? To link it back to our little case study, our case study is Maria, an email client. So where it might come in is, let's supposing we want our app to support URLs that look like this, where this is the variable part, and this might be a user's inbox identifier. Now, all I'm going to do is show you that the component that's mounted can actually access this piece of data. It'll just display it on the screen. I'm not going to do anything with it, but that will be sufficient to prove that the component can actually access it. So the first part of the puzzle is, how do we tell the React router in our configuration that there is a parameter within the path name, and this is how we do it here. So the colon symbol tells us that what follows is a parameter. You can give any name to the parameter that you want to. So I've decided to call it user ID, but that's essentially kind of a variable name. So that tells React router where a parameter exists within a path. And then the next thing is, how does our component that's mounted access this particular value? So there's a couple of steps involved in this now. Well, strictly speaking, it's going to be passed in as a prop. Now the prop is a special prop that is created and injected into our component by the React Router library. So the prop is called a match prop. It's an object. It has a key called params, which is also an inner object. And that then will have a key based on the parameter name that you decided from your routing configuration. So this entire expression here is going to access the inbox identifier or the user ID from what's currently being displayed in the browser's URL address. Now, this expression just doesn't work suddenly. We've got to do an extra little bit of coding in order to get it to work. Ordinarily, this would throw an undefined exception back at us. So how do we resolve that? And the answer is here. We've got to use a special function that's provided by the React router, and you pass your component to this function and it returns an enhanced or enriched version of your component. And notice that's what I'm actually exporting here. So it's the component that is returned by this function. That's what you need to plug into your routing configuration. This WAD2 function is classified as a higher order component function. Higher order component functions is a technique that we use quite a lot, actually, or certainly it's used by a lot of third-party libraries and the React router, the React framework itself. And in general, it's a technique where you can use it to take one of your components and enrich it with some extra aspects. In this case, the enrichment comes in the form of extra props that are made available to us. So for example, the match prop and the history prop are two that are made available by the WAD2 function. So let's see all this in action. Moving up to sample 3. Now we'll look at the code in a second, but I've got two hyperlinks here on the home page just to illustrate it. So when I click on these, if you just observe what's happening in the browser's URL address. So if I take this one, so we have /inbox/123 before, and the inbox component is mounted, and I'm proving to myself here that I'm actually being able to access that particular inbox number. Essentially, I'm getting it from the browser's URL address. If I go back to the home page and click on this link, now it's 4321, and my component is actually picking up the right value. So I'm proving to myself that my inbox component can access the parameter that's contained within the URL of the browser. And this is the component that the code that we saw there a moment ago. So the full sample here's my routing configuration. So all that has changed is this one here. Here's my home page with the hyperlinks. And I've used both examples actually. I've programmed one of the hyperlinks using the link component. I've programmed the other one using the anchor tag. Both will work in this case. I should probably have used the anchor tag here as well. Or sorry, I used the link component here as well, but the anchor tag will work. So here's my inbox component, and as I've already said, it's what the with router function generates. That this function takes your component and outputs a new component, and it's that component that we're actually exporting. So that's the one that is being injected into, or that is being wired into my routing configuration, as in here. So far I've said that all of our routing configuration for our app is centralized in one component, which is at the top of our component hierarchy. But you can actually have route entries contained within your own custom components. And we would refer to these, or the React Router library refer to these as nested routes. The general kind of use case for it is if one of your components, if one of its children is somehow determined from the browser's current URL address path. So to apply it to our little case study, so this is one of our standard routes that we have at the moment. But supposing we have a case where the URL address could actually look like this. In other words, there's a /statistics part. And if the URL is like this, then we want both the inbox and a stats component to be mounted onto the DOM. So the stats component is going to be a child of the inbox. Whereas on another occasion, the URL might look like this. And if it is, then we want our inbox component to render a draft as one of its children. So the routing logic that would achieve these two, we can put that routing logic into the inbox component. We don't have to put it in the top level routing component. And so here's an excerpt from the inbox component, and you can see as part of its JSX, we actually have route entries. And the route entries are referring to the particular child that I want to have mounted in addition to the inbox. So let's see the sample in action. So again, I've just got some hyperlinks to demonstrate it for convenience. So this hyperlink is telling me that it's just going to mount the inbox component on its own. But if you observe the URL now, so the URL looks like this. and the inbox component is generating this, which we had from before. Whereas when I click on this hyperlink, you can see that I have /statistics as part of the URL. And so now what I'm seeing is the inbox component is generating this output, but the stats component is generating this output. And the third example then is I have a URL that has /drafts as part of the inbox. So now the inbox component is generating this, and the drafts component is generating this. I still have my about and home as before. They haven't changed. And so most of this sample is as before. So that hasn't changed. So my top level only has a reference to the route that would cause the inbox component to be mounted. There are my convenient hyperlinks just to demonstrate it. And the inbox component then is, as we saw from the slides. So you can have these route entries buried within your own custom components. Now, you know, that's really a kind of a design decision as part of the overall design of your React app, deciding what are the different URL paths that it should support, and then identifying opportunities to use these nested routes might be part of the design process. The last example we'll look at in today's lecture is extended link idea. So when we click on a hyperlink that's programmed with the link component, okay, our new page is mounted, but supposing we wanted to pass some custom props to that page that it would use, how do we actually do that? And it turns out that there's two forms of the link component that allows us to do it. So to demonstrate it, it's kind of an artificial demonstration really, but let's supposing in my inbox hyperlink here, which I've implemented with the link component, I want to pass some additional props to the inbox page itself. And this is how I've programmed it. So here's my link component, but the top prop this time takes an object rather than the string as before. And the structure of this object is dictated by the React Router library. So my path name is specifying what I want the URL of the browser to change to. And here is how I pass the additional props. Now I've hard coded them here, but presumably they would be computed in a real life situation. So the stats object has a set of key value pairs. And these key value pairs now are going to be props that will be made available to whatever component is mounted as a result of the browser's URL changing to this. In our case, in our top level routing configuration, it's going to be this route entry here is going to match it. And that says you should mount the inbox component, and inside of the inbox component, this is how I get at the additional props. So essentially this props.location is another special prop that's made available to our component by the React Router library. And all I'm doing here is destructuring the stats object to get at my two custom props. I'm not doing anything with them other than displaying them, I think, but it's sufficient to demonstrate how you can pass props to a component via a hyperlink. And you can look at sample 5 in your own time. Now, there's just one or two aspects of the router configuration that I want to go back to, and I'll demonstrate them using sample 1. So here's our configuration, and we know how it works. So if my URL changes to /about, it goes to the About page. I go back to the home page, and let's say the URL is /about/us. It still finds the About page, and that's because it's the nearest match that it can find is how it works. So that URL there is the closest to it is this one here. So it's happy with that. Now, you might notice down here I'm using an extra prop called exact. If I had used that up here, essentially now I'm saying the URL has to match this exactly. Otherwise, don't use this route. Try and find another one. Of course, it won't. But if I save that, and now if I go to the About page, and now if I try /about/us, this is now going to send me back to the home page because this URL doesn't match the /about route exactly. The second point is the order in which you put these may affect how your app behaves. So what the React router does is it goes through these in the order in which they're presented, and the first match that it finds, that's the one that it accepts. It doesn't go looking to see, is there a better match further on in the list. So let's make some changes here. Let's get rid of this. And also let's move it up to here. Okay, so that's our routing configuration. Save those changes. And what we're going to find now is if the browser's URL is /about, then obviously this will apply. But when we make it /inbox, it won't actually use this one. It's going to use this one because I've gotten rid of the exact prop here now. And so this is the nearest match so far that it will have found for a match to /inbox. Let's prove that. So that's my home page. About works. But inbox brings me back to the home page. And the reason again is because this URL, when it tries to look for a match, obviously this doesn't apply, but this is a close enough match. It's not an exact match, but I didn't say it had to be an exact match. So it decides, well, this is the route that it will use. It never actually gets to check this one at all because it is already determined this will do. If I reinsert the exact prop there though, now I'm back to the kind of behavior that I had before. So if I go back to the home page, so the point being, Number one, you do need to pay attention to the order in which you put these, and you should use the exact prop on certain occasions to ensure that the right route is picked. And it really depends on the specifics of your app as to whether you need it or not. Now, there are some other samples that we need to work through, but we will cover those in a subsequent lecture. So the title, Design Patterns, is not specific to web apps. It's actually an aspect of software engineering in general. And just by definition, what a design pattern is, and it's specified there at the bottom of the screen. A design pattern, I'm saying, is an abstracted, repeatable solution to a commonly occurring problem in software design. So kind of what has happened really over the decades is that as software engineers, we have been coming across similar types of problems that we want to implement solutions to. I'm talking about problems now at the micro level rather than at the macro level. And over time, the design of these solutions are good quality designs to these problems have kind of emerged, and they've been cataloged and documented for the rest of the community to use them, really. In fact, the text, the image there that you see on the left is the cover of a text that was published way back in 1994. So, you know, as a topic, it has been around for many, many decades. Now, I want to relate it to web apps, and specifically to web apps developed using the React framework. You can see there from the book title, it relates more to the world of object-oriented development, so languages like Java, C++. But even the design patterns that were documented in this text, they can be actually applied to areas of web development as well, as it turns out. So anyway, this is what design patterns are. They are well-founded, abstracted solutions, design solutions to commonly occurring problems in the area of software development. Now, in relation to software design, reusability and separation of concerns, I'm sure you've heard of these before. These are kind of high-level design objectives that we have. By reusability, what we're trying to get at there is the ability to implement modules or units. Units now in the context of a React app would be a component. A unit in the context of object-oriented Java development might be a class. We're looking to develop units that are reusable either within an application or across applications. By separation of concerns, we mean we'd like each unit to really just have one single responsibility. And why is that a good idea? Well, it's probably easier. It's more directed at maintainability and understandability. If each of the units within our overall application has a single responsibility, and provided it's well named, then it's easy for other people to understand our code. And also, it's probably easier to maintain our code. So we'd like to achieve these. They're kind of interrelated, the two objectives, and they are a design objective. Related to this is the notion of the DRY principle, where DRY stands for don't repeat yourself. The idea being that nowhere within your code base for a particular application should you have code that is repeated multiple times, albeit there may be slight differences between the repetitions, but it's obviously not a good idea. What we would obviously do in that kind of situation is to abstract the repeating code, put it into a unit of its own, and reuse it wherever it needs to be used. So dryness, reusability, separation of concerns, single responsibility, these are all objectives or principles of good software design whether it be web app development or any other type of software development. Now, in order to try and achieve these, there are, in general anyway, two kind of approaches that you might take to modeling your problem domain, as we say. So whatever you're trying to develop an application for, that's what we're calling the problem domain. And we're analyzing the problem domain and we're trying to come up with some sort of overall high-level design for it. Then when you're analyzing the problem domain, you can either view it through the prism of inheritance or through the prism of composition. What I mean by that is with inheritance, you're looking for is-a type relationships in your problem domain. So for example, a car is an automobile. So if I was developing an application and car and automobile would be concepts in the problem domain, then if I was using an inheritance approach, and let's supposing I was using a language like Java, then I would have a class of type automobile and I would have a class of type car, where car would inherit from the automobile class. That's your typical inheritance type relationship. An alternative way of viewing your problem domain is to use a composition approach. Now, this is probably going to be less familiar to you. You are certainly familiar with inheritance, but in a composition approach, what you're looking for is often referred to as has-a type relationships. And to stick with our case kind of study, if you like, we might say that a car has an engine. And so we would model that. We would maybe have a car class, but one of its properties would be an object of type engine. So it's just two kind of different ways of looking at the world and modeling the world. That's what we're trying to get at here. And they're equally valid. But as it turns out, the React framework veers towards the composition model, which is really where I want to take this discussion. And it's also going to be something new for you. Now, in that vein, taking a composition approach towards modeling a problem domain and trying to achieve greater reusability, better separation of concerns, improved dryness in your code base, then the patterns, there are three patterns that have emerged in the React world over the years, and I'm listing them there. And I just want to look at each of them and show you examples of code using each of them. And we will also use, well, we'll use the first two in the Movies app. We don't get an opportunity to use number 3, but you may see an opportunity to use the third one in your own assignment, maybe later on. Although that's not necessarily a high-level requirement that I have. So these are three patterns, three design patterns based on the composition modeling approach that we would like to use in our React code base. Before I talk about the three patterns, just to get a term out of the way, HTML, as it turns out, actually, HTML, if you could, it's a language in a sense, but it is based on the kind of composition approach. And the two little code excerpts that I'm showing you there, then the way we might express it is to say that if we take the one on the left, we would say that a div is composed of a H2 and a UL, or at least this particular div is, whereas on the right, I have a div that is composed of a paragraph and an image and a hyperlink. So HTML actually allows us to compose elements in any way that we want to. If we go back to the excerpt on the left, then we would also say that the div has 2 children, H2 and a UL, and on the right, our div has 3 children, So it's this term children that I'm just introducing here, because that actually comes into play when we start looking at React components and composing React components with other components. So the first pattern we will look at is the container pattern. Now, I'm saying here that a React component has a special prop called the children's prop. It has been there all the time, but we haven't used it up to now. And what it allows us to do is to pass components to other components. And we do that by nesting it within the JSX. So if you see my simple picture component here, in the middle of its JSX, I'm referring to the children prop. So how does this get its value? Where does it get its value from? But whatever it evaluates to, it's obviously going to be inserted into the middle of this JSX of picture. And on the right, I'm showing you in general how you control the children prop. So whatever you put here is going to be bound to the children prop of picture. And you can see the way that I'm using picture here. I have its open tag and its closing tag. This is very HTML-like, and that's what's nice about React components. We can follow the same type of syntax as we do with ordinary HTML tags. So whatever goes in here gets essentially bound to this expression here, and so will be displayed here. And so that what this effectively allows us to do is to decouple the picture from what it includes in its output to the screen. And hence we can reuse picture in many different scenarios. So it's this idea of decoupling is one of the outcomes. And so if we take a couple of illustrations, what it now means is that if I take this example here, where I'm using picture, but in this case, I am telling it I want to include a button with the picture. So the image is going to be displayed and the button is going to be displayed. The image is coming from the picture component itself. If I go back to the previous slide, the picture displayed an image. Okay, we passed it what the URL of the image was. We didn't worry about that. But what it displays after the image is up to what we're calling the consumer. The consumer is the component that's using the picture. So for this example, it's going to display a button. Whereas here, I'm getting it to display a list with the image. Here, I'm getting it to display whatever my complex component is with the image. So I'm reusing the picture for different use cases. And that was one of my objectives, this idea of reusability. Another way I could describe what's going on here is to say that my picture is being composed, my picture component is being composed with other elements or components. So that's the kind of classic example of composition going on.